Today we will study some problems regarding the chapter 3 motion in a straight line. Okay, so straight away we will solve some exercise problems. Let me take the first problem here. Okay, a woman starts from her home at 9 a.m. walks with a speed of 5 km per hour on a straight road up to her office 2.5 kilometers away, stays at the office up to 5 p.m. and returns home by an auto with a speed of 25 km per hour. Choose suitable scale and plot the xt graph of her motion. Now here a woman, she is going to office. She leaves the home at exactly 9 a.m. and reaches the office at 9:30, which is at a 2.5 kilometers away, and she stays in the office up to 5 p.m. in the evening. Now after 5 p.m. she returns to home by an auto, okay, with a speed of 25 km per hour. Now we have to draw the xt graph for her motion. Now before that one, we have to work out what is the time taken by that woman while walking to the office and while returning back home by an auto. That we will work out. The velocity of the woman by walk is given 5 km per hour. If I convert it into terms of and velocity of the woman by an auto is 25 km per hour. Now we will work out what is the time taken. Okay, the distance of the office from the home is 5 km per hour. Now what is the time taken by the woman by walk? That we will work out. Time taken by walk is the distance traveled divided by the velocity. Now 2.5 divided by 5. So it is 0.5 hours or 30 minutes. In terms of minutes, if it is written, it is 30 minutes. After 5 p.m. she returns to the home by an auto. Therefore, the time taken by auto is 2.5 km distance divided by the velocity is 25. It is 0.1 hour. If you convert it in terms of minutes, it is 6 minutes. By walk she is taking 30 minutes and by auto she is taking 6 minutes. Now we will choose a suitable scale and plot an xt graph for her motion. Okay, so look here. Now along the x-axis we are taking the time. Now along the y-axis we are taking the position. It is in kilometers. Okay, now these two axes are meeting at the point O, and we will choose some suitable scale for the x-axis. Now we start with 9 a.m. and 10 a.m., 11 a.m., 12 p.m. and 1 p.m., 2 p.m., 3 p.m., 4 p.m., 5 p.m. and 6 p.m. along the x-axis, time axis. Now along the position we are choosing 0.5 kilometer, 1 kilometer, 1.5 kilometer, 2 kilometer, 2.5 kilometer and 3 kilometer. So we have chosen a suitable scale. Now exactly at 9 a.m. she starts walking and she walks for 30 minutes to reach her office, now which is at 2.5 km away. So therefore we have to draw a straight line as shown by that blue color line. She walks to the office for 30 minutes. Now that is the 9 to 9:30 minutes. She started from 9 a.m. and reached the office exactly at 9:30. Why it is 9:30? She took 30 minutes by walk. From 9:30 onwards, she remains in office and works in the office. Therefore, from 9:30 to 5 p.m., look here, from 9:30 to 5 p.m., she is in the office. Therefore, we get a straight line which is parallel to the time axis. Okay, therefore we are having, oh no, this is by walk. Now we have a straight line, that yellow line represents the straight line. Now she stays in office up to the 5 p.m. After the 5 p.m. she is returning to the house or home by an auto. Now that is given by this violet color straight line. Now look at the slope of the blue color and the violet color. Now blue color is having more slope and blue color is having a lesser slope and violet color is having a steeper slope. So therefore now this one is by auto. Now this graph represents the xt graph of that woman going to office, staying there and coming back to home. Okay, like this we can draw the xt graph. Now second problem. A drunkard walks in a narrow lane, takes 5 steps forward and 3 steps backward, followed by 5 steps forward and 3 steps backward, and so on. Each step is 1 meter long and requires 1 second. Plot the xt graph of his motion. Determine graphically and otherwise how long the drunkard takes to fall in a pit 13 meter away from the start. Now here we have a drunkard here. Now he is moving. He is taking 5 steps forward and 3 steps backward. Then again moves 5 steps forward and 3 steps backward. So that means he is taking 1 second. He is taking 1 second for 1 step. Now 1 step corresponds to, here it is in 1 meter. Now we have to plot a graph here. Now we will plot the xt graph. Now this is the x-axis, that is along the x-axis we have taken time with respect in seconds, and we have the position graph along the y-axis. So it is in terms of, it is in meters, position is in meter. Now we will choose a suitable scale. Now here O is the origin and choose the suitable scale. Now 5 seconds, 10 seconds, 15, 20, 25, 30, 35, 40 seconds. Now along the y-axis we will choose a suitable scale, 1 meter, 2 meter, 3 meter, 4 meter, 5 meter, etc., etc., up to the 14th or 15th meter, because that pit is 13 meters away from the drunkard. Okay, now we have to plot the xt graph for the motion of a drunkard. Now look here carefully. Now drunkard start from the origin. First he moves forward with 5 steps and he takes 5 seconds. So for the first 5 meters or 5 steps he is taking 5 seconds. Therefore we get a straight line here. Look here. Now that blue color line, it is representing the first 5 steps. Now in the coordinate we have x coordinate and y coordinate. X coordinate is time and y coordinate is position. Therefore after 5 seconds he has traveled a distance of 5 meters. In the next moment he puts 3 steps backward. He is coming backward with 3 steps. For the motion of these 3 steps he is taking 3 seconds. So therefore now that pink color line, it is showing 3 steps backward, and the position coordinates for this one is, time is 5 plus 3, it is 8 seconds. The position is 5 steps forward minus 3 steps backward, therefore 2. So 8, 2 is the coordinate at this position. Now from this graph we can say that after traveling 5 steps forward and 3 steps backward, what is the displacement of the drunkard? It is only 2 steps. Okay, look here. He is taking 2 steps in 8. Now in the next moment he moves further 5 steps forward as shown by that blue line. Now what is the position coordinates? Now 8 plus 5, it is 13. And distance is 2 plus 5, it is 7 meters. From that position he is stepping backward with 3 steps in 3 minutes. Now he is stepping backward and the position coordinates are 13 plus 3, it is 16, and 7 minus 3, it is 4 steps. Coordinates are 16 and 4. So in the same way we are calculating. Now in the next step he is taking 5 steps forward with 5 seconds. Therefore 16 plus 5, it is 21, and distance is 4 plus 5 is 9. Now at that point he is stepping backward with 3 steps. Okay, So time is 21 plus 3, it is 24. And the position is 9 minus 3 because he is moving backward. That is a 6. Okay. Now from that position he is moving forward 5 steps. So 24 time is 24 plus 5, it is 29. And the displacement position is 6 plus 5, it is 11 meter. From 11 meter. Now from this point he is stepping backward. So 29 plus 3, it is 32. Time is, and the position is 11 minus 3, it is 8. Now from this position he is once again stepping forward. Now what are the coordinates here? Look here. Now 32 plus 5, it is 37, and 8 plus 5, it is 13. But in the problem the pit is at a distance of 13 meter from the starting position. Now at this position he is reaching the pit and he falls down. Then what is the time taken here? It is 37 seconds from the starting position. Now this vertical dotted line represents the position, represents the time, and vertical horizontal line represents the position. It is 13 meters away. Therefore he took 37 seconds to reach the pit. Okay, like this we will work out the xt graph of motion of the drunkard. Okay, we move on to the next problem. A jet aeroplane traveling at a speed of 500 km per hour ejects its products of combustion at the speed of 1500 km per hour relative to the aeroplane. What is the speed of the latter with respect to the observer on the ground? Now here a jet aeroplane is moving in one direction. If we choose the direction of motion of the jet aeroplane as positive, now it is emitting the exhaust gases. Those are the products of combustion at the speed of 1500 km per hour with respect to the aeroplane. So here the velocity of aeroplane with respect to the ground is given, and relative velocity of combustion, products of combustion with respect to aeroplane is given. Now we have to calculate what is the velocity of products of combustion, that is exhaust gases, smoke emitted by the aeroplane with respect to an observer on the ground. Now look here, we have an aeroplane which is moving in the forward direction. It is taken as positive. At the meantime it is emitting the exhaust gases in the opposite direction. Now aeroplane speed is given 500 km per hour and exhaust gases are 1500. Since exhaust gases are moving in the opposite direction, we will choose its velocity as minus. Okay, once again look at that aeroplane moving in the forward direction, the combustion gases are moving in the backward direction. Now forward direction motion of the aeroplane is taken as positive and backward motion of the aeroplane is taken, and the backward motion of that gases is taken as negative. Okay, now we'll work out what is the velocity of product of combustion with respect to an observer in the ground. Now velocity of aeroplane VA, it is positive plus 500 km per hour, and relative velocity of combustion is given, combustion with respect to the aeroplane, that is VCA we call. Velocity of aeroplane is VA and velocity of combustion with respect to aeroplane is VCA is minus 1500 km per hour. Why I have chosen minus here? The combustions are in the opposite direction to the motion of the aeroplane. Now we have to calculate velocity of combustion with respect to an aeroplane is given by the formula VCA is equal to VC minus VA. Now with this relation we are going to calculate what is the velocity of combustion VC with respect to the ground. Okay, therefore velocity of combustion with respect to the observer or the ground VC is given by VCA plus VA. Now substituting the values, VCA is minus 1500 plus VC is 500, therefore it is minus 1000 kilometer per hour. Now this is the velocity of the products of combustion with respect to an observer on the ground. Move on to the next problem. A car moving along a straight highway with a speed of 126 km per hour is brought to a stop within a distance of 200 meters. What is the retardation of the car assumed uniform, and how long does it take for the car to stop? Now here a car is traveling with a certain velocity. Now brakes are applied, and after applying the brake, it has moved through a small distance and stops. Now this distance we have already called it as stopping distance, that is given 200 meter, and initial velocity of the car is given 126 km per hour. What will be the final velocity? The car is going to stop, therefore final velocity becomes 0. Now here we have to calculate what is the decreasing acceleration, that is called as retardation here, and also we have to calculate the time. Now look at here, a car is moving here. Now the moving car, whenever the brakes are applied, it moves for a short distance and stops there. Okay, once again look at that one. A car is moving with an initial velocity. Okay, now the driver is going to apply a brakes. When the brakes are applied, it moves through a small distance, that is stopping distance, and finally it comes to rest, stops. Now this is fun. Now this distance traveled by the car, as shown by that yellow line, it is given 200 meter stopping distance, and initial velocity of the car is given, it is 126 km per hour. If you calculate its velocity in terms of meter per second, we have to multiply it by 5 by 18. Now 18 ones are 18 sevens are 7 fives are, it is 35. Therefore 35 meter per second is the initial velocity. After applying the brakes, the car comes to rest. Therefore final velocity V is 0, and the distance traveled, stopping distance, it is 200 meter. We have to calculate the acceleration. Now by using the third kinematic equation, v square is equal to v naught square plus 2ax, okay, substituting the values, now v is 0 and v naught is 35 whole square plus 2 into a into x, that is 200. So 35 square is 1225 plus 2 into 200 is 400 into a. So therefore minus 400 into a is equal to 1225, or a is equal to minus 1225 divided by 400. Now if you work out this one, if you calculate with the help of a calculator, you will get minus 3.06 meter per second square. Okay, this is the acceleration of the car which is assumed to be uniform. Now here we are getting negative sign, that indicates acceleration is decreasing, and hence it is called retardation. Now we have to calculate what is the time taken for the car to stop. Now use the first kinematic equation, v is equal to v naught plus 80. Now 0 is equal to 35 minus 3.06 into t. Therefore 3.06 into t is equal to 35, or t is equal to 35 divided by 3.06, and if you work out this one, we will get 11.48 seconds. Now this is the time taken by the car to stop. Like this we will solve the problems. Now we move on to the next problem, problem number 5. Two trains A and B of length 400 meter each are moving on two parallel tracks with a uniform speed of 72 km per hour. So two trains are moving in the same direction in two different parallel tracks with the same speed, that is 72 km per hour in the same direction, with A ahead of B. The driver of B decides to overtake A and accelerates by 1 meter per second square. If after 50 seconds the guard of B just brushes past the driver of A, what was the original distance between the two trains. Now here they have given two trains which are traveling in the same direction, and the velocities are given train's velocity. Now look here, two trains are traveling. A train is moving ahead and B train is little bit back. Now this is the distance between the two trains. Now this initial distance here we have to calculate. Okay. A train is moving forward and B train is coming in the back side. They are moving with the same velocity, that is 72 km/h. If that is the case and they have given the data, what are the velocity of the two trains, since they are traveling in the same direction, therefore the velocity of train A is 72 km/h. If we calculate in terms of meter per second, so we will get 72 into 5 by 18, so that is equal to 20 meter per second. Similarly, train B is also moving with the same velocity, 20 meter per second. Both are moving in the same direction, but train A is moving ahead, train B is behind. Now here we have to calculate what is the initial distance between the two trains. For that one, what they have given, the driver of train B decides to overtake train A. Then what he has to do? He has to accelerate the train. Therefore train B, now in the second case, train B is moving with an accelerated motion, but train A, it is moving in the same uniform velocity. Therefore for the train A, acceleration is 0. For the train B, acceleration is 1 meter per second square. With that data, we are going to calculate what was the initial distance between the two trains. Now how will you work out this distance between the two trains? Now we have to first calculate what is the distance traveled by train A, S1, without accelerated motion, and distance traveled by train B, S2, with accelerated motion. Now train B decides to overtake train A. Now look at the next slide. Now here train A is moving with the same constant velocity, but train B decides to overtake train A. Look at that one carefully. Now driver of train B, he accelerates the vehicle, therefore the train B is moving a little bit faster. Now he has to overtake train A. Now it is overtaking. At what point it is going to overtake? We will stop the motion of the two vehicles. Okay. Now it has overtaken. Just now it has overtaken. Now once again look at that motion of the two trains here. Now train A is moving with a uniform velocity. Its acceleration is 0. But the driver of train B decides to overtake train A. Therefore he accelerates the train. Now it is moving a little bit faster velocity. Look at that one. Okay. Now it is going to overtake. It is going to overtake. It is going to overtake. Now finally it overtakes at the end of the slide. Okay. Now at this position, now this is the position. We have to calculate what are the two distances traveled by the two trains. Now train A has traveled through a distance. It is taken as S1, that we have to calculate with 0 acceleration. Okay. Train B, it travels this much of distance, that is equal to S2, with an accelerated motion. Now separately we have to calculate S1 and S2. Now for the train A, velocity is 20 meter per second and acceleration is 0 because it is moving with a uniform velocity. Okay. Now for the train B, it is also velocity is same initially 20 meter per second square, but it is under accelerated motion. A is equal to 1 meter per second square acceleration. Now after 50 seconds of distance traveled, the train B just overtakes train A. Therefore time traveled by the two trains is also given 50 seconds. Now by using the second kinematic equation, we will work out what was S1 and S2. Now for the First train distance traveled by A is given by S1 is equal to, use the second kinematic equation V naught t plus half at square. Since acceleration is 0, the second term is 0 here. Therefore S1 is equal to V naught is 20 and time is 50. Therefore 1000 meter. Now this is the distance traveled by train A in 50 seconds. Similarly, we will work out what is the distance traveled by train B in the same 50 seconds with an accelerated motion. A is given 1. Okay. So by use the same kinematic equation, now S2 is equal to V naught t plus half of at square. V naught is 20 and t is 50 plus half into A is 1 and t is 50 square. Now 50 square is 2500 divided by 2 is 1250 and V naught it is 1000. So therefore S2 is 2250 meter. Now we have to work out what was the initial distance between the two trains. That original distance is given by S2 minus x1. Therefore it is 2250 minus 1000, it is 1250 meter. Now here we have solved this problem based on the motion of B with respect to A. Okay, you should remember this one. We have taken the motion of B with respect to A, not with respect to the ground. Clear? Move on to the next problem. On a two-lane road, car A is traveling with a speed of 36 km per hour. Two cars B and C approach car A in opposite directions with a speed of 54 km per hour each. At a certain distance, when the distance AB is equal to AC, which is 1 km away, B decides to overtake A. Does what minimum acceleration of car B is required to avoid an accident? Now here there is one car which is moving in one lane. In the other lane, two cars are approaching. One is from the forward direction, another one is from the backward direction. Now the driver of B car decides to overtake first car, therefore he has an acceleration. Okay. Now what was the minimum acceleration required for the car B? Now we will visualize with this simple animation. We have a road here. Now the first car, that green color car, we take it as A, which is moving with a certain velocity it is given. Okay. Now in the opposite direction, two other cars are approaching. Now there is a blue color car, if we take it as B, and pink color car is coming from the forward direction, it is taken as the car C. Once again have a look at the motion of the cars. Now green color car A, it is slowly traveling from the opposite direction, and from the back two other cars are moving in the other lane. From the opposite direction a pink color car is approaching, and from the back side another blue color car is approaching. Now this is the case. Now as and when the distance AB and AC becomes equal to 1 km, now here the position of A is given and B is given and C is given. Now here AB is equal to AC, equal distance, now they are 1 km away. Now at this position, the driver of B, who is coming from the back side, he decides to overtake the car before C does. That means he has to accelerate. Now we will work out what are the velocities of the three cars. Now VA is given 36 km per hour. If I calculate in terms of meter per second, it is 10 meter per second. Similarly, we will work out VB, it is 54 km per hour. If we calculate the velocity in meter per second, it is 15 meter per second. But it is moving in the same direction, that is towards the right, we take it as positive. But car C is moving in the opposite direction, therefore its velocity is minus 54 km per hour. Now if you calculate in terms of meter per second, it is minus 15 meter per second. Now in order to calculate the acceleration, we have to first work out the relative velocity of the cars. Now the relative velocity, now at this position, look here, now the driver of B decides to overtake the car A before the car C just passes A. Now look at this animation. Now the driver of B is moving forward fast and he just crossed or overtaken the first A car. Once again have a look at that one animation. Now driver car B it just overtakes before the car C has overtaken or passed the first car A. Now the car B has an accelerated motion. That acceleration we are going to calculate. The relative velocity of car B with respect to A is Vb minus Va, that is 15 minus 10, it is 5 meter per second. Similarly, the relative velocity of car C with respect to A, it is Vc minus Va. Now Vc is minus 15, Va is minus 10, therefore it is minus 25 meter per second. Why it is minus? Because car C is moving in the opposite direction. Now for car C, the distance travelled is 1 kilometer, that is 1000 meter. We will work out what is the time taken to reach the car C. Okay, therefore x is equal to v0 t plus half at square. Since car C is not at all moving with an accelerated motion, therefore a is 0 for car C. Since car C is traveling in the opposite direction, the distance traveled is 1000 meter. It is taken as negative. Therefore, its displacement is in the opposite direction. Therefore, minus 1000 is equal to its velocity is also in the negative x-axis direction. Therefore, minus 25 into t. Therefore, time taken is minus 1000 divided by minus 25. That is equal to minus minus get cancelled. Therefore, we get plus 40 seconds. The car C has taken 40 seconds. Similarly, the car B has to take the same distance at the same time. He has to travel the same distance with the same time with a relative velocity and with an accelerated motion here. Therefore, acceleration we have to calculate. Therefore, the distance traveled for the car B is the same. Therefore, x is equal to v0 t plus half at square. Here it is moving with an accelerated motion. Now substituting the values, x is 1000. Now for the car B, since it is moving along the positive x-axis, we have taken distance as plus and velocity is 5 into 40 plus half into a into t that we have calculated earlier, it is 40 square. Now 40 square is 1600 divided by 2, it is 800. And we get 1000 into 5 into 40, it is 200 plus 800 a. Now 1000 minus 200, it is 800. Therefore 800 is equal to 800 a. Therefore acceleration a is found to be 1 meter per second square. Now this is the minimum acceleration required for the car B to overtake just before car C does. Like this we will work out. Now the next problem. Two towns A and B are connected by a regular bus service with a bus leaving in either direction every t minutes. A man cycling with a speed of 20 km per hour in the direction of A and B notices that bus goes past him every 18 minutes in the direction of his motion and every 6 minutes in the direction of opposite, that is in the opposite direction. What is the period t of the bus service and with what speed assumed constant do the buses ply off the road? Now here there are two cities A and B. They are having regular bus services. Now buses are traveling with a time period of t minutes. For every t minutes, one bus leaves on either side of the station. Now there is a person who is cycling with a speed of 20 km per hour. He notices that a bus moving in his direction, it goes past him after every 18 minutes. And a bus coming in the opposite direction, it goes past him in every 6 minutes. Now with these data, we have to calculate what is the time period t of the bus service and what is the velocity of the bus. Now velocity is assumed to be a uniform here given. Now first we will work out velocity, relative velocity in the same direction. Now the relative velocity of the bus with respect to the cyclist, VBC we call it as, is equal to VB minus VC. Now bus go past after every 18 minutes. For every 18 minutes it is crossing the cyclist. Therefore in terms of hours it is 18 by 60 hours. Now what is the distance travelled by the bus with this relative velocity? Therefore the distance covered is VB minus VC into 18 by 60. Now this is the distance travelled. Okay. Now this is with respect to the relative velocity. Now after t time, another bus starts with the same velocity, that is VB. VB is the velocity of the bus. Therefore distance covered by this bus in time t seconds, that is worked out. Since bus leaves after every t minutes, the distance covered by the bus with the velocity VB is given by VB into t by 60. It is in terms of hours. T by 60 is in hours. VB into t by 60. Now these two distances are equal. Therefore we will equate them. We will get an equation. Therefore VB minus VC into 18 by 60 is equal to VB into t by 60. 60 get cancels here. Therefore we will simplify this one. It is 18 into VB minus VC, that is equal to t into VB. Okay. Now this is one equation we are getting. Now similarly we will work out the relative velocity for the bus coming from the opposite direction. So it is given by VBC is equal to VB plus VC. For opposite direction of motion, the velocity gets adds up. Okay, that we know. Therefore, after every 6 minutes, buses go past after every 6 minutes. That is 6 by 60 hours. Therefore, the distance travelled within this time is given by VB plus VC into 6 by 60. Now, since bus leaves after every t minutes, the distance travelled by the bus with the same velocity VB in t seconds is given by VB is equal to t by 60. This one is calculated similar to that of the first case. Now, these two distances travelled by the buses are equal. Therefore, we will equate them. We will get VB plus VC into 6 by 60 is equal to VB into t by 60. Now 60 get cancels. Therefore on simplification we will get 6 into VB plus VC is equal to t into VB. Now we get another equation for the second case. Now taking the ratio of these two equations and simplifying for velocity of the bus. Now what we will get taking the ratio? We get 18 into VB minus VC, that is equal to t VB, and 6 into VB plus VC is equal to t into VB. Now here t into VB get cancels. So on the right hand side, and 6 ones are 6 threes we are getting. Therefore 3 into VB minus VC divided by VB plus VC is equal to 1 we are getting. Okay. Now cross multiplying that one, 3 into VB minus VC is equal to VB plus VC. Now 3 into VB, if you take VB on one side, therefore 3 into VB minus VB, it is 2 VB, that is equal to 3 VC minus VC. It is minus 3 VC, it is moving to the right hand side, therefore it is plus. Therefore we will get 2 VB is equal to 4 VC, or VB is equal to 2 times VC. That means the velocity of the bus is twice that of the velocity of the cyclist. Now velocity of the cyclist is given, it is 20 km per hour. Therefore the velocity of the bus is 2 into 20, it is 40 km per hour. This is the velocity of the bus. Now substituting this value in either equation, We will take the second equation, that is 6 into Vp plus Vc is equal to T into Vp. Substituting the values, velocity of the bus is 40 and velocity of the cyclist is 20 is equal to T into 40. Now on simplification we will get 360 on the left hand side is equal to T into 40. Therefore 360 by 40 is 9 minutes. Therefore time period of operation of the buses is 9 minutes. That means for every 9 minutes a bus is leaving from both the cities in both directions with a velocity of 40 km per hour. Now like this we will solve these problems. Thank you for watching this video.